Hello everyone, today I'm going to try to solve a time value of money problem. This is related to the problem of annuities. Annuities are complete bitch, difficult to visualize, and I'm going to try to use Python and a Jupyter notebook to do it. So on to the problem. There's a 34-year-old investor going to retire at the age of 60, that's after 25 years. She expects to earn 12.5% on the investments for the next 25 years, and after that she'll earn 10%, and she wants to withdraw 25,000 per year beginning for each year for the 30 years of her retirement, post her retirement. And the question is, how much should she then invest at the end of each year for the next 25 years. So she is 35 now 35 now, and plans to retire at 60 and expects to live till 90. And what she also expects that every year of her retirement she'll be withdrawing a sum of $25,000, and the question is, how much should she be investing in the meantime? If we were to reduce the problem, it basically means that from the age of 35 to 60, the future value of inflows till the age of 60 should equal to the present value of 25k or outflows present value at the age of 60. First, let's write a few functions. First function is to calculate future value of annuity. So let's define it. Every annuity, and what I need cash flow, I need a rate of interest, and I need period. Okay, let's set up a counter for every year during the period. Let's start off with the amount which is 0. So today I am at year 0 and I am going till year whatever period, say 25, which will be a period over here. So till the year is less than period plus 1. I'll come back to this, why I did a plus 1. How much do I have every year? So how much I have is, I have my original amount of the previous year. I earn some interest on it, which is R. Let's say I pass the value in percentages, so I have to divide by 100 to get to the absolute value. Yeah, and I also earn the cash flow for that year. So at the end of the year, this is how much I have, right? And my year increases by 1. My first cash flow is at the end of each year, so it's going to be at the end of year 1. So let's start with I equal to 1, and therefore it will go from 1 to 25, and hence when I becomes greater than 25, which is 26, we should exit the loop, which is why the period plus 1. And when you exit the loop, just return amount, right? Okay, so far so good. Now let's calculate present value of annuity. Note something peculiar over here. In order to be able to withdraw 25,000 per year at the beginning of the year, is what is called annuity due. So while my earlier annuity started with I equal to 1, at the end of the year, this starts right at I equal to 0. So let's again define a function around present value of annuity, and let's call it annuity due. Again, I need a cash flow, I need the rate of interest, and I need a period. I is equal to 0, amount is equal to 0, annuity due. And so while I is less than period, not period plus 1, because this is annuity due. Okay, so for every year in the period, what will be its contribution to the present value? It's going to be the present value of the cash flow discounted, to the year. So it's going to be, so the amount will be amount plus whatever is the cash flow divided by 1 plus R divided by 100 raised to the power of I. Perfect. So for the year 0, I is going to be 0, which reduces the denominator. Anything raised to 0 is 1, so which means amount is 0, which means it will be only the cash flow, which is right. It's a slightly different calculation from the future value of annuity. And I move my counter, increment my counter by 1, and when that is done, return amount. Nice. Now let's get down to our calculations. So what is the future value of 25k at retirement? Oops, I meant present value. It will be PV, annuity due, the function which we created. Cash flow is 25,000. The rate of interest 10%, and it's for 30 years. Here's a small trick. We need to figure out how much to invest every year for the next 25 years to essentially end up with a kitty which is this big. Let's figure out, if I just invest $1 every year, then what's going to be the future value? So what's the future value of $1? This is going to be future value annuity $1 at 12.5% for 25 years. Suppose I invest $100, so the future value of annuity will be 100 multiplied by the future value of $1. So if I know how big is the kitty I want, I can simply divide it by the future value of $1 to arrive at how much should I be investing every year. So annual investment works out to, let's just copy paste these. And let's print out the answer. Let's round off the answer because I don't think anyone will be interested in decimal figures 0. And I think we are good to go. Let's see if the code works, else we debug it. Oops, went into a loop. Okay, what's the problem? Why did it get into a loop? Syntax. It should be plus equal to. It should be plus equal to. So whenever there is the same term on both sides, like over here, what you can easily do is you can just write it as plus equal to. So it will basically take the amount and put it, right up here. And same over here. And don't do equal to plus, which sends the system into a never-ending loop. Okay, so let's see. And voila. The answer is annual investment required is $1,800, and I sort of know this is the right answer.